My guest this week is Dr. Matthew Wielicki, a geochemist and earth sciences professor whom you might already know from his insightful posts on X. He runs a popular Substack at irrationalfear.substack.com, where he challenges mainstream climate narratives by actually looking at the published science. He also has a book coming out soon called Irrational Fear. I've invited him to discuss the latest media focus, the alleged impending collapse of the Atlantic Ocean currents, commonly known as the AMOC, and which include currents like the Gulf Stream, which act like a giant conveyor belt to vent heat from the Atlantic into the Arctic. According to the mainstream narrative, there are growing signs that continued global warming could weaken the AMOC, with media often pointing to increasing meltwater from the Greenland ice sheet as the trigger. They say that stalling these currents would plunge northern Europe into a bone-chilling 5 to 15 degrees Celsius temperature drop. Media outlets like The Guardian, Science Daily, Phys.org, and YouTube videos with millions of views all warn of a critical Atlantic current collapse within decades. As evidence that we're teetering on the edge, many point to the historic example of the Younger Dryas, a 1,200-year-long cold snap that started 12,900 years ago, with temperatures similarly plunging between 5 and 15 degrees Celsius, triggered by the collapse of glacial Lake Agassiz, which dumped a colossal 21,000 cubic kilometers of meltwater from the North American ice sheet into the Atlantic, thus fundamentally disrupting the AMOC. And it happened again around 8,200 years ago during the awkwardly named 8.2 kiloyear event, when another 100,000 cubic kilometers of meltwater, again from glacial Lake Agassiz, disrupted the AMOC, causing a somewhat milder 160-year-long cold snap. I reached out to Dr. Wielicki to unpack this doomsday scenario to see what the science actually says. Hint, it's quite different from the media's narrative, and to bring some much-needed geologic context to show how the truth is far more fascinating than the hype. Dr. Wielicki, welcome to the show.
Thanks, Julius. Thanks for having me.
You bet. Thanks for coming on. Yeah, I wanted to start off, like since we're going to dig into the AMOC, maybe you could just kind of give a brief sort of a steel manning of what their actual claim is as to this doomsday scenario that's about to happen.
Yeah, so the AMOC or the AMOC, that stands for the Atlantic Meridional Overturning Circulation. And this is the primary way that the Atlantic Ocean moves heat from the tropics, where the solar radiation is concentrated, up towards the poles. And it's essentially how the planet kind of acclimates itself and keeps a steady temperature. It's really the oceans that drive climate. That's where most of the CO2 is stored. That's where 72% of the Earth's surface is covered. It holds much more energy than the atmosphere. And so it's really what drives the climate, especially in the northern hemisphere for places like the UK and northern Europe. And so the most recent claim is that the models are suggesting that with continued warming, the AMOC, this current, will start to weaken or possibly shut down. What that would mean was that warm waters from the equator would not be moving north towards Greenland and towards the UK, which is what makes their climate much more temperate, and that would create catastrophic climate change in especially those regions where you would see plummets of temperatures on the order of 5 or 10 degrees Celsius. So global warming is going to cause global cooling or regional cooling in the UK if this current falls apart. And so that's the primary claim. And it's like with everything else, warming isn't really a problem. Elevated CO2 isn't a problem. We know the planet's been much warmer with much higher levels of CO2. It's all these add-on effects. It's these cascading effects that will these kind of feedback loops that they develop. Those are really what they need in order to kind of drive the crisis. So it's really not the warming that's a problem. It's all these other add-on effects, and this happens to be the flavor of this month.
How is this supposed to work that meltwater off of Greenland is going to suddenly stall this current? Like, I mean, I'm
Yeah.
trying to wrap
So
my head around how they're even envisioning this is supposed to happen.
right. So the idea is that if you inject a lot of fresh water that has a low salinity, that's cold, into the system, that you'll disrupt the system. The claims are that we've seen this in the past with things like the Younger Dryas, these climatic shifts that we know have happened in the northern hemisphere. We have a hard time explaining. And one of these hypotheses is that these old glacial lakes that were existing on the land masses as we were coming out of our last glacial cycle, those injections of really fresh, cold water into the AMOC current destabilized the current enough that we saw these big climatic shifts. In the Younger Dryas, we saw shifts of 8 or so degrees in the northern hemisphere around Greenland, for example, in the order of just a few decades. So on the order of something like 10 times or 20 times what we see today that we call a catastrophic climate change was natural. And so they were trying with the hypothesis and trying to explain this. One of them is that this freshwater injection, it disrupts the saltier warm water that's moving in from the surface that eventually cools and sinks. It sinks because it contains a lot of that salinity. If you put that cold fresh water on top, it will block as a dam almost. It will stop this current from coming up north, and that will shut off the entire conveyor belt, and thus you get this dramatic climate change especially in the regions of the North Atlantic around the UK, Northern Europe primarily.
I mean, in the case of the Younger Dryas, I mean, there was visibly a massive glacial lake, that glacial lake Agassiz, which is, I think, equivalent to, like, or the remnants are like Lake Winnipeg here today. But I mean, there's this huge body of water that suddenly releases in a very short period of time. Whereas I think, like this is where I find the claim so crazy that, where's this vast volume of water? Like you're not talking about ice drip or water dripping off the end of the glacier. Like there's got to be this sudden flush to destabilize something, not a
It, the
slow
the
trickle, right?
That's right, but the flush is the melt sheet. It is the Greenland melt sheet. Although it's been losing almost no mass for the last 20 years, there's been almost no cooling in the Arctic
Yeah.
in terms of ice mass in the last 20 years. A recent report just mentioned that. It's when you have these models. So remember, this system is just like climate, these ocean circulation systems, they're uncoupled, nonlinear, chaotic systems. What that means is that means one equation can't really dictate the system, so they're uncoupled. You need lots of different equations, and each will have an effect on each other. It's nonlinear, so changing one variable is not easily predictable in how that will change the next variable. And it's chaotic, meaning you can't look at the patterns of the past to predict the patterns of the future, because in a chaotic system, essentially, by definition, there are no patterns. And so what that means, though, in terms of models, is models are incredibly attuned to their boundary conditions. The initial conditions that you set for the model are extremely important. And so they can play around with these models enough that they can tweak the initial conditions such that they get sufficient melting, even though we don't see it today. It's not in the observational data. And they can increase this melt runoff to be somewhat equivalent to things like these giant lakes that existed in Canada. That actually we see the riverbeds where we think that they funneled out into the Atlantic through the Great Lakes. And so they're just tweaking models to essentially get an answer. And once they get that answer, they know they can run with it, and they know the media will jump on board because it's predicting a very catastrophic and extreme event.
Yeah, in your recent pieces, you've been pulling up what the actual scientific data says, which is kind of completely out of whack with what the media narrative says. So,
They're exactly opposites of each other. So this is something that I find is very common in this field. There's zero accountability. The models will say something and they will make predictions, and they made these predictions 20 years ago as well. Now we have a lot of really good observational data. When the first IPCC came out in 1990, they were making certain predictions. I give them a pass because we didn't really have a huge buoy system. We now have this rapid array, which is a giant buoy system that sits out in the Atlantic current that is measuring this. And so we have the data now. Back in the day, if you made these predictions, I give you a pass. But now the observational data is very clear. We know that, for example, the Florida current, which is a primary limb of the Atlantic current, has had no change at all. So that they do a very sneaky trick, because there was a paper that was published in Nature that said the Florida current's been incredibly stable for decades. The drift that we saw was actually electromagnetic interferences, because they were measuring this through these cables that were on the seafloor. So they made the correction for the cable, and they said, look, there's been almost no change. It's insignificant. There's the stability is what's amazing in their paper. Well, what the new paper did was they took their original estimate of zero point 0.8 sievert drips, which is just a weird number, but it's a million metric gallons of water per second. So it's just how much water is moving through a metric meters per second is how much water is moving through the system. And they used their original number without acknowledging that they made a correction for the electromagnetic interferences. And they completely omit the fact that it was stable for 40 years. And they take the original number and run with it. And they even cite the paper in their paper. I mean, I really think this newest paper is borderline scientific fraud. They omitted papers that were just published this year from Nature that say even in the most extreme modeling, the Atlantic current is stable. It's just remarkable that they get away with this stuff. And I mean, the paper that they basically omit completely is called. I mean, the title is wonderful because it basically says the name. It says continued Atlantic overturning circulation even under climate extremes, published just 2 months prior to this new paper, and it's basically completely ignored.
So it's this complete cherry picking I mean, I noticed that in the research that I've done online, trying to like pull up stuff like when I wrote my book there, that the anything that doesn't fit the narrative is just completely ignored. Like I mean, you've talked about like the degree of this cherry picking.
Yeah, and it's what's fascinating is that's what they accuse people on my side of doing is cherry picking. And I'm like, if you took a holistic view, you would include all these papers. Like I've published a bunch in the scientific literature. I'm sure I've omitted papers that were relevant to the research in things like background or methodology. But when you're actually making your argument about in the discussion section, the meat of a scientific paper, you really can't omit things that came out just a couple months ago. And if you did, your reviewers surely would catch that and say, hey, you have to at least reference this paper and talk about it and say why you disagree or what they got wrong. This was published in Nature, a very prestigious paper, a journal. And so, the fact that all of this gets missed really shows you that it's a coordinated effort. This isn't just slipping through the cracks. It's not an accidental omission. This happens repetitively all the time. The reviewers are part of the game, the editors are part of the game, these big journals are part of the game, and everybody just kind of perpetually feeds the anxiety machine, the fear machine, because that's what brings in more funding, that's what gets more people involved, that's what the media likes to put out because it gets clicks. So it's this self-perpetuating kind of monster that keeps growing. And unless we start calling it out, we're just going to be getting really bad information. We're making $1 trillion policy decisions on really bad information. And so that's my biggest fear with two young kids is, we need the field of science was about sharing and getting information to people, but it has to be accurate information. And if the whole system is now corrupted to push a narrative, it really makes me scared of what the future is going to bring.
Yeah, I mean, I look at it and I mean, it just crushes my faith in the scientific process all the way across the board. That I mean, it's like these are some of the things like, from my own background where I can see the problem, but how many other areas are there where I have no idea what's being pushed and it sounds plausible and I go with it, right?
Absolutely. And these are experts in their field. I mean, these are well respected people. I'm sure they are smart and I'm sure they do good science, but they get captured by this narrative and they know that this is the thing that kind of keeps the spigot going, that keeps the funding going. Don't rock the boat. We have a good thing going. And I found out clearly as an academic when I was at the University of Alabama that if you started to rock the boat, everybody turns on you. I mean, you can't be in the community and go against the narrative. It is taboo. You get kicked out. It's much more religion and ideology than it is scientific debate nowadays.
Yeah. Yeah, I found it's quite striking when you read a lot of the scientific papers how, the results tell you something that challenges the narrative. And then in the conclusions, you can almost see the researcher begging, like, it's like, this makes us rethink, but it doesn't challenge the narrative. Like they're trying to very carefully put out something that's challenging without ending up on the wrong end of a cancel culture mob.
The IPCC is great at this. If you read the working assessments, that's kind of the scientific groups that are working on this thing, as opposed to the summary for executives and policymakers. There's a huge disconnect. Hurricanes is a great example in the IPCC. The IPCC admits that there's no global trends in hurricane frequency or intensity, but they take all of these little tiny nuanced region things, and that's what they put in the summary of policymakers. They bury the fact that there is no trend, and they kind of hype on the fact that, well, models suggest there may be trends in the future, and we're going to have supercharged storms, and then they bury the fact that none of this is actually in the observational data. Like I said, in 1990, I would give them a pass because we really didn't have the instrumentation we do now. We didn't really know what was happening in terms of precipitation in Uganda, for example, in 1990. But we do today. We really do have good instruments pretty much all over. Satellites are wonderful for global coverage. And the narrative really does fall apart when you start to look at the observational data. And the worst part is there's no accountability. They never go back and say, hey, we really screwed this up. We got this wrong in the last report. Our predictions were way off. Everything is happening in a different way. We still don't fully understand it, but there's just zero accountability. They just keep ratcheting up the rhetoric.
Yeah, I mean, sort of taking the AMOC as the example, like it seems like the whole thing is built on this idea that, everything's fine today, but we're approaching this tipping point. I mean, is this tipping point idea purely a model-driven thing that in order to, like, I can never wrap my mind around these mechanisms that suggest that our planet is this extremely fragile thing that can just be sort of flicked with a tip of a finger and thrown in off kilter.
I hate that. I hate that, especially young people think that they hold the planet in their hands. Our planet has had super volcanoes, mega tsunamis from impacts whizzing in. It's gone through big solar events, polar reversals, supercontinents coming together and breaking apart. A little bit of CO2 and some plastic bags in the ocean isn't going to disrupt the entire planet. It doesn't mean we shouldn't clean that stuff up and be, good stewards of the planet. It is the only planet we know of that hosts life. And so I definitely am a proponent, especially a father of two young kids, of protecting the planet. But this idea that it's so fragile and that any changes we have are going to send us in a tipping point, how can you answer that question? I approach it from my geology background, and I say, well, let's look at the geologic record. If we know that there's been some sort of state changes in the geologic record, let's look at those and figure those out. Well, one tipping point, for example, that they like to harp on is that if the polar sea caps melt, and the AMOC would be part of this, the albedo would change dramatically, and now more solar radiation would be absorbed because the ice is white, the oceans are dark blue, so they absorb much more radiation than the ice reflects, and we would go into a runaway greenhouse, and we would be Venus in some amount of years, right? Well, I can look at the geologic record, and for example, the last 550 million years, that's what we call the Phanerozoic eon, we were predominantly ice free. So the vast majority of that time period, we didn't have ice at the caps. We call the current time period an ice age. And the fact that we are now with ice at the caps tells me that clearly that's not a tipping point because we have cyclically back into a regime where we have ice. We also know that CO2 levels have been 10 times higher than they are today, yet now they're low again. So clearly raising CO2 levels doesn't it create some sort of runaway CO2 machine where we end up with 96% CO2, like, for example, Venus. And so, from the geologic record, I would argue there is no evidence for tipping points. Tipping points are very convenient to make kind of BS thresholds, such that when you bypass that threshold, you can tax and regulate people more. And, it's 6 feet apart. You ask people where they got 6 feet apart. Literally, they made it up. They made it up sometime on a conference call. And this is the same thing as 1.5 or 2 degrees of warming. When I dug into that, that was over a discussion between two economists that came up with this 1.5. No scientific input, zero scientific training, no understanding of the geologic history. So these are thresholds that people make that we will pass, surely, because they make them such that we will pass them, such that they can say, look, now we really have to double the panic, double my funding. But in terms of tipping points, I think this is more propaganda than it is science.
Yeah, I mean, looking at the Younger Dryas or that 8.2 kilo year event, When I look at that, I mean, the idea that this is purely because of meltwater, like even that to me seems like it's a simplistic explanation. Like, going back across most of geologic history, it seems like there's always many different things that have to come together to actually significantly shift anything. I mean, if the 8.2 kiloyear event had 100,000 cubic kilometers of water, and the Younger Dryas had only one-fifth of that, and yet it had much more significant cooling. I mean, that alone suggests that there's more to the story.
Absolutely. This is something that we always do as scientists. We take really complex systems and we try to break them apart into much simpler little boxes. We can study that and try to identify something in that. But I agree with you 100%. Almost all of these things are going to be a combination of events. It's one of the things that I used to work on a lot was impacts, for example. People argue all the time whether it was the Chicxulub impact that caused the dinosaur extinction or whether it was volcanism in the the Deccan traps. It was probably a combination of the two. They're both affecting the system, and when you have a double whammy like that, and so surely maybe a draining of Lake Agassiz was part of it, and then there's some evidence that we had some magnetic drift at that time, that the magnetic field may be weakening at that time. So there's a lot of interactions that we just don't understand. We've been getting good data for a few decades, maybe 100 years with instruments on the ground on a planet that's 4.5 billion years old. We're just starting to scratch the surface of these interactions, these 10,000, 100,000 million year cycles that we still have never even been through a half a percentage of. It's very difficult when you've only experienced such a small portion of it. But of course, as humans, we're trying to figure this out. We kind of grasp at straws sometimes in geology. We work with the evidence that we have and we try to make a story out of it. But if there's one thing I hope scientists, the climate science community needs a little bit more of, it's humility. It's admitting that you don't know all of it. It's the idea that they used to say the climate is settled. I mean, the science is settled. Just to try to shut people like me up is the biggest backfire of all time for them because now, as the observations come in, we're learning it's so much more beautiful and complex and nuanced than they wanted to reduce it to. And so it's a little bit of humility back in science would be a really wonderful thing.
Yeah. Yeah, I mean this AMOC system, as far as I understand it, also shut down 4,200 years ago. Again, I think it's called the 4.2 kilo year event. And yet, as far as I can see, there isn't any evidence of a massive flush of glacial water coming into the system at that time. So I
That's
mean,
right. That's right. So that's really important because the Younger Dryas and the 8.2 kiloyear event both are right in our coming out of the last glacial maximum. So you have a dramatic amount of warming. But for about the last 5,000 years, if we look at sea levels, they've been relatively stable, plus or minus maybe 1 or 2 meters. So clearly, and CO2 levels have been stable. So clearly, something else was going on there. And there's evidence again that there was maybe something going on with the magnetic field 4,000 years ago. And maybe we have a 4,000 year cycle that we still don't understand that we're approaching right now. We are going to be approaching a solar minimum as well, so that's gonna have an effect. And so it's just the fact that we reduce all of this stuff down to just the simplistic idea of a trace gas. It's just it really makes a beautiful system like climate just so simple and dumb to me. And the truth is why do we do that? Well, you can't tax the magnetic field. You can't really regulate the magnetic field, right? So they're going to push aside anything that they can't do policy on. Because let's be honest, right? The IPCC is a policy making machine. That's what it's there for. It's not there to do anything in terms of environment or anything. It's there to write laws and to move money into the people that fund them. And so you ignore the things you can't tax and regulate, and you really focus and just kind of manipulate the science to show that it's the stuff that you can tax that's really driving the system.
yeah, I mean when I was thinking about like the Roman warm period and the medieval warm period. I know you've written about the medieval warm period as well. Like if any kind of warming triggers a flush of cold water, like you would think that those would have also shut down the AMOC, and yet there's nothing like that visible in the record, is there?
Nope, not at all. And both of those, so the way that they try to get rid of the medieval warm period is they say it was just regional. and it was maybe only isolated to the northern hemisphere. Well, that's where the AMOC shutdown happens. It happens in the Beaufort Sea and the Laurentia Sea. It doesn't happen in the Southern Ocean. There's no estimate or predictions of melt runoff in the Southern Ocean disrupting it. So that would be the place where you would see it. But now we're finding evidence from the peninsula in Antarctica that there was dramatic warming during the medieval warm period there. That's pretty much as far south as you can get. And so it really does seem like this was a global phenomenon. It happened with no change in CO2 levels, and it happened with no change to the AMOC. So to me, what that suggests is we should be ready for climatic shifts. We need to build in resiliency regardless of the CO2 that is out there. And we should stop pretending that if we lowered CO2 to pre-industrial levels, that the climate would be stable, because we know in pre-industrial levels it wasn't stable.
Yeah, I mean, it almost seems like the claim that the AMOC gets shut down as soon as there's warming suggests that it actually suggests that the system is buffered to prevent any kind of shift in climate. Like it's sort of like not a positive but a negative feedback loop that actually locks things down, and that also doesn't make any sense in this context.
No, and Gaia is real. The Gaia hypothesis, the planet self-regulation. Remember that what we are doing on the planet in terms of CO2 release over the last 150 million years or 150 years, those things do happen when we have these large basalt flows, these traps, the Siberian traps, the Deccan traps, this huge voluminous release of magma that comes, lava that comes to the surface. And we know that we have major changes in the CO2, but the planet buffers itself. It has a self-regulation, right? So greening increases, deserts shrink. There's more evapotranspiration. You start to bury more CO2 in weathering products. You make more calcium carbonates and corals. And so there is this self-regulation, but it does actually have a natural variability, and things do get out of whack occasionally. But now with climate science, it's almost like you find one little thing that's changing, and now you have really good instruments to identify this subtle change. And then you can say, look, because we didn't have instruments in the past that would have ever identified this change, it's never happened before, it's directly anthropogenic, and we need to make radical changes to stop it. And AMOC is a great example, but I gotta admit, I didn't have the idea that the UK, who's switching to a bunch of solar and wind energy, having the cooling and more cloud cover as part of my climate crisis bingo card. I really thought that they were concentrating on heat waves and things like this, but now they're flipping the script completely, and now it's going to be too cold. Maybe solar panels aren't the best idea. If you're going to drop 5 or 10 degrees, you're going to have snow on them. I know how my solar panels work in Colorado when there's snow on them. They don't work great. And so, it's just, it makes me so frustrated that they grab onto any little thing. And even if it argues against what they've been saying the whole time, which is it's the heat waves that were the problem, and that's what was going to kill people in Europe, and it was the old folks that were going to suffer, and we didn't have AC. Now we flip the script and say it's going to be, a global warming winter in the UK and in Northern Europe, and it's going to last decades. And this is going to be, the climate killer now. And so it's just so frustrating. And I really understand why the young people I used to teach at University of Alabama had so much anxiety about this. I mean, every day it's something new. It's going to be too hot. It's going to be too cold. It's going to be droughts. It's going to be floods. It's going to be no snow. It's going to be tons of snow. It's just like, I mean, all day long they get bombarded with this stuff. And they just have no ambition. They give up hope. They're like, why not just throw my McDonald's wrapper out the window? The planet's going to light on fire in 10 years. So who cares? Like, why would I be a good steward of the planet?
Yeah, it's almost like this catastrophism where you take the whatever short-term trend that you see and just project it out into infinity while ignoring all the things that, as you say, this self-regulating system, right?
And ignoring all the
Yeah.
observational data that shows that we've had decades now of stability in the AMOC, even though CO2 levels have gone up, sea surface temperatures have increased. We do see some melting of the Greenland and Antarctic ice sheets, but yeah, that's boring, right? That
Yeah.
doesn't get the clicks.
That's
What
right.
gets the clicks is that, oh my gosh, it's going to be catastrophic.
Yeah. Yeah, I mean, even the idea that warming automatically suggest that there's going to be a more drought is actually counterintuitive from a geologic point of view, where you see the fact that there's more evaporation from the oceans, which means that it always translates into more rainfall on land, local variations, notwithstanding.
Sure, absolutely. And I mean, if you've ever traveled to the tropics, you know that warm air holds more humidity. It holds
Yeah.
more moisture, right? This is the Klaus-Clapeyron equation. And we know that warm air holds a lot more moisture. So in theory, you would think that that would necessarily be a good thing. One thing that is very precious on our planet is fresh water in the liquid state.
Yeah.
So we have a lot of fresh water, but it's primarily locked up in ice. Something like 80 something percent or more is locked up in ice. And so we have very little fresh water, but we have a growing population. We've been really relying on aquifers, and those aquifers replenish very slowly. And so having a little bit more fresh water precipitation, in my mind, would be a great thing for human civilization. What a wonderful way to help irrigate crops and to feed people, to replenish some of the aquifers that we have now depleted. And so, but the claim is that any change in the system, it's almost like they expect stasis. And any change in the system is anthropogenic climate change. But if you want stasis, go to the moon. The moon is stasis. That is, it gets warm on the day side for the lunar day. It gets cold on the night side, but there's no weathering. There's no weather. You get little micrometeorite bombardments and things like that. But that's stasis. But it's also death. So on a planet, stasis is death. We know that for sure. When we were talking about tipping points earlier, I think that there was a tipping point that we were approaching, but it was on the lower end. It was on the end of cold and low CO2. And that we really do think there is a threshold that we've never touched. In the upper part, we've gone through all of the upper part up to 7,000 or something ppm. Coral reefs were happy, dinosaurs were happy. We were little mammals that were hiding from being stomped on dinosaurs at the time, but we were doing pretty well as well. And so, there's definitely no threshold in the upper portion that I see. Once you get up to like in the thousands, we do see some human effects where if breathing that much CO2 does affect cognition and things like that. There's no estimates that we would ever get to that point. But there definitely may be a threshold at the lower end where if you approach 200, 180 parts per million globally, that photosynthesis really starts to struggle and maybe starts to shut down. If you shut down photosynthesis, you kill the planet.
Yeah, yeah. I think that if I remember correctly, the geologic record shows quite clearly how the plant life is actually struggling at those lower CO2 levels.
Absolutely, and we've seen it now since the first NASA satellites that were going up to measure greening have been up now for decades, a couple decades, and
Yeah,
so we have good evidence where we see that not only is the green area expanding, but the leaf density on trees is increasing. So the trees have more leaves than they did before. That means they're doing more photosynthesis. So there's just no evidence that, and until we get into really high CO2s, that a gentle elevation of CO2 is a problem. But there is definitely evidence that below a certain threshold, the way we know that is the planet never has gotten below that threshold.
yeah,
And so, we're not approaching anything in the increasing regime that we haven't seen in the geologic record, but we were approaching something in the lower regime that we have never seen in the geologic record. That makes me much more apprehensive in the lower portion than it does in the upper portion because I see that the planet has experienced this before and all the plants and animals did just fine.
yeah. Because as far as I remember, like most of the plants that are common today they evolved somewhere between 2 and 5,000 parts per million, which is quite a significant jump
Absolutely.
from here.
And if you look at mammals, so mammals evolved about 190 or so million years ago. We are in the coldest era for mammals of all time. So, mammals as warm-blooded, right? We need to produce our heat. We are in the coldest realm that we've been in ever in our evolution. I mean, obviously humans weren't around until just, maybe 2 million years ago or so. But the idea that's the temperature or something that we were at pre-industrial levels was something optimal, was some sort of climate optimum, was better for the planet or for the plants and the animals on the planet is absurd. It really is. I mean, we were going to go into another ice age. Hopefully, if the CO2 story is at least partially correct, then we may have increased CO2 enough right now where these oscillating cycles, which we call Milankovitch cycles, that's how the Earth is interacting with the sun in its orbit and on its axis, maybe those won't plunge us into another ice age. I think that we can deal with a few inches or maybe more of sea level rise in places like New York City. A good chunk of the Netherlands is under sea level. New Orleans is under sea level.
Yeah.
I don't know how we would deal with a kilometer of ice on top of New York City. That seems to me like a much more difficult engineering problem to solve than, gentle sea level rise. So hopefully if there is anything to the kind of CO2 is driving the climate story, maybe one thing that we inadvertently did was to keep us out of the oncoming ice age.
Yeah, I mean, looking at previous ice ages, it seems like the temperatures usually peak right after the warm, like right after you come out of the ice age, and then already start to very slowly go back down afterwards. And I mean, haven't we seen that as well in our cycle, like where things peaked around 8,000 years ago?
That's right. So we call that the Holocene climate optimum. So we really do think that pretty much now again, the IPCC says, yeah, these were regional places, and no, we're
Yeah.
above that now. But if you look at most of the geologic sites that we have, that for example in the Canadian Rockies, we have 7,000-year-old trees, full-grown 100-year-old trees that are melting out of the bottom of the glaciers. It takes a long time for those trees to move into that area, to establish, to grow for 100 years to get to that size. So clearly these aren't sneaking under the ice and growing. There was a forest there, and now there's ice, and that ice is receding and exposing that forest. And so it seems to me that we were in that cycle, and this is the argument from a lot of the IPCC folks, is no, we were in a natural cooling trend. And so my argument is, should we have stayed in that cooling trend? Would you want that cooling trend to continue? If there was anything we could have done, we hopefully would have stopped that cooling trend. We know that the little ice age was devastating to Northern Europe. I mean, crops, diseases, political infighting, you name it. I mean, it was when the climate gets cold, we suffer. We have no evidence that when the climate warms gently that we suffer. So far right now, the human condition has never been better. Less people die of famine, less people die from conflict. There are no climate refugees. I think Al Gore said there should be 1 billion climate refugees right now. I know why. I was a refugee that immigrated from Poland and came here to the United States. We didn't come because of climate.
Yeah.
Right? These people aren't on the southern border because it's too hot in Honduras or Guatemala. They're coming for economic opportunity and for prosperity. Right? There is no such thing as a climate refugee. And so it just comes back to that same story. The observational data doesn't match these grandiose predictions. But the grandiose predictions ensure that the authors get more funding, they get the media exposure. Nobody talks about the fact that I write that this might be scientific fraud, and they omitted all these papers. I sent it to the journal editor, no response. I sent it to the journal itself, just their info. I don't know where that goes, but no response. I sent it to Nature that says, look, they're omitting in this other paper, they're omitting your publication. Like that, this is that you should be upset about that. And no response because Nature's part of the whole problem as well. And so, there's this, it's not a conspiracy. It's not one person pulling the strings, but
No.
it is a system that feeds on itself and feeds on kind of panic and fear. And that's what drives the money coming in. And so if you keep ratcheting up the panic and the fear, you keep the money coming in. And it just, and as a young academic who doesn't have tenure at the time, most of those people put their head down and shut up. You just got there. You probably went through a postdoc in grad school. You got student debt. You just got your dream job. You put your head down. You don't say anything. I don't have a self-preservation instinct, so I couldn't keep my mouth shut when I saw this. Plus, I had just had kids, and I just was seeing the effect, the mental health effect on kids, and I figured it was worth it to speak out. But that's the main disconnect. It's the fact that we use models and crystal balls on these computers to drive panic and fear, and we ignore the observational data.
Yeah, I mean, when you started speaking out, was there kind of did it start with a quiet pushback against you, just sort of kind of go like, shush, this isn't worth it, and then kind of grew from there, or how did it?
So from the students' perspective, they were very refreshed. I
Yeah.
mean, I had people bringing their friends to my lectures. It was a 342 person class. And there would be people standing around. They were like, "Hey, I brought my buddy. I heard you're giving your climate lecture." And he's like freaked out about climate. So I brought him along. I'm like, "Yeah, awesome. Bring them all." They were very refreshed. They've been, these are 18, 19, 20-year-old freshmen, sophomores. They've been pounded in their head since they were first could read in their little kids' books that the planet's on fire, that it's going to burn up. There's a doomsday clock on some building somewhere counting down, like literally counting down. So they just
Counting
grew
down to the next reset for another
to
10 years.
to when they shift the goalpost. Yeah, they just move the goalpost, kick the can down the road, ask for
Yeah.
more money, of course. But they don't know that, right? Because they haven't
Yeah.
experienced that yet. We
That's
we
right.
as old farts, we've kind of gone through that already,
Yeah.
and so they were very refreshed. A lot of my colleagues were like, "Hey, you're crazy, but I kind of agree with you. Like I'm not going to say it."
Yeah.
But then, there was the flood of emails, the flood of phone calls to the chair, to my president of the university. The PR campaign against me was huge.
Yeah.
So I mean, I was told not to come to faculty meetings anymore, which I was like, that was the best thing they could have ever done. If you've ever
Mhm.
been to a faculty meeting, it's a nightmare. So that was the best thing the bureaucracy ever did for me. I was like, thank you. I will gladly not go to another faculty meeting. But it was clear that you just couldn't have this type of vocal. I was pretty vocal at the time. I was on TikTok. I was on social media. I was giving these lectures to enormous amounts of people. If you were that vocal and that kind of pushy like I was, that you just couldn't rock the boat that much. Everybody knew that this kind of, although it may be a little bit BS and we may be manipulating things a little bit and we may be really affecting the mental health of young people, it brings in a lot of funds and it brings in a lot of publicity, and let's just not rock the boat. I just thought that the detriment we're doing to science, the next time we have a really big thing that we need to help science help us with, like COVID, we're going to have no trust in science. And COVID did it again. And now we've lost absolute trust in science. It's just, I really cherish the institution of science. I think it's made society incredibly better. But it's because we trusted science, and scientists had some humility and admitted when they were wrong. And we would argue and then go have a beer. But
Yeah.
now it's like we argue and no, you want to kill grandma because you didn't wear a mask, or
Yeah.
you're against driving an EV, or you pretend that you're not going EVs aren't going to solve the problem, and mandates for things like that. And so, it's become almost like you can't have a disagreement anymore. The disagreement is so ingrained in our like ideology, or not really mine. I'm willing to disagree, but in
Yeah.
this other side's ideology, that even though we agree on 98% of things and we probably disagree on 2%, where I believe in climate change. I believe that humans have an effect on the climate. I just don't think that CO2 is the control knob. And so we disagree on that tiny little aspect, and that's enough that I have to be kicked out of the club.
Yeah. Yeah, I mean, I find it wild coming from a geology background to see all these other things that have, clearly shaped the planet just being sort of erased from the conversation to focus, myopically on this CO2 as this knob, as you're saying, right? I mean, I had one example that I wanted to pull up to talk to you about was like the the early Eocene climate optimum, which is I think 54 to 49 million years ago, where like temperatures are starting to decline after the dinosaurs went extinct, and then all of a sudden you get this massive spike of 12 to 14 degrees Celsius warmer, and yet again everything gets put through the lens of CO2. Like where is this sudden burst of CO2 coming from versus like all like the fact that as far as I understand there was this plume of magma under the Barents Sea that blocked off again that the AMOC that it blocked off the venting of warm water into the Arctic, and that produced then of course this warming of the Atlantic that raised global humidity levels, which then the water vapor actually being the real greenhouse gas.
Absolutely. That's one thing that is commonly overlooked, is that CO2 isn't even the major greenhouse gas. It's not at all. It's water
Yeah.
vapor. When I was learning about atmospheric science, I took atmospheric chemistry in like 2009, and we were taught on the order of 90% or so is driven by water vapor, with 10% all the other greenhouse gases, with CO2 being the dominant one in that subset. But now the arguments are something like, oh, water vapor is only probably 60%, and it's 40% greenhouse gases, and which CO2 is the dominant of that subset. Because of course, you if you want to tax something, it's difficult to tax water vapor, right? It's we don't like that's a really tough one when you live on a planet that's 72% ocean. It's difficult to tax water vapor, but it's easy to start taxing greenhouse gases. And so it just comes back to the money. You ignore the things you can't tax or regulate, tectonics, right? Well, you can't really tax tectonics, and you're not going to really change that, right? The rise of the Himalaya probably had a lot to do with that Eocene
Yeah.
thermal max, and it's probably had a lot to do with now our decline in CO2 that we've seen, the added weathering that has been
Yeah.
going on with that enormous mountain range. And so, but you can't tax those things. Those things are just completely swept under the rug because there's no policy that can be made from those. There's no money that can be extracted from those. So we can't allow those to become part of the conversation because then it muddies the waters for what we really want to go after, which is the greenhouse gas. And we can't muddy the waters because then it kind of makes our taxes and our policies not as clean cut and dry. And so everything else gets swept under the rug. The IPCC is the worst at this. Everything else gets swept under the rug, and you just focus on the things that you know you can affect policy and extract money from. And so you just forget about things like all of the changes like the Eocene optimum and the fact that the Himalaya is probably driving a lot of the CO2 decrease. It just all of that stuff is just forgotten about.
Yeah, I mean, I find it kind of ironic that in the case of the early Eocene climate optimum, where you actually have this massive blockage, like physical blockage of the Atlantic currents venting into the Arctic, that in that case, that this is sort of ignored and it's all CO2. Like, I mean, this is
It's
it's
interesting
kind
that
of
we
ironic that
also
yeah,
it's interesting we also call those the optimums. So we
yeah,
called it the Holocene optimum as well,
yeah,
right? So optimum means optimal, like better, good, beneficial, right?
flourishing,
So
yeah,
well, yeah, flourishing. Why are we admitting that these warm periods are optimums, but then trying to argue at the same time that the cold regime that we were just recently in is the one we should stay in?
yeah,
It just makes no sense. But it does if your idea is to extract money, right? And to increase the amount of government interference in your life. Because remember, CO2 is everything. You're a CO2 life form. As I speak this sentence, 40,000 ppm of CO2 are coming out of my mouth. We have a carbon-based economy. We live on a carbon-based planet in terms of our surface, in terms of the life on the planet. So this is everything. It's what you eat, it's what you drive, it's where you live, it's how you commute, it's where you work, it's how you vacation, it's everything and anything. So if you're a government that is interested in kind of figuring out how you can nitpick and get involved in people's lives and extract some money and some power, climate is the perfect tool.
yeah. I mean, actually, this brings me to your another article that you wrote the other day, a couple months ago, in which you called it "Is it really our CO2?" So I wanted to ask you this for the paid subscribers as a bonus question. You basically made a case based on some of the scientific literature that's been published that the amount of CO2 that's increasing in the atmosphere, that actually that we may be massively overestimating how much of that is a human contribution, that there is actually a fair bit of data suggesting some other sources that are not actually being recognized to the same degree. So before we get into it, I wanted for the everyone else, I really wanted to thank you for coming on. When is your book coming out?
Oh gosh, well, let's hope sometime of spring of next year.
Oh, fantastic. And it'll be called Irrational Fear.
Irrational fear, climate change.
So the same as your Substack.
That's right.
Fantastic. And your handle on X?
At Matthew Wielicki.
Thank you so much for coming on. I really appreciate it. This was fun.
Thanks, Julius.